Module 26211, Control Systems and Fundamental Concepts, Section 3.0.0, Low Voltage Control Systems. Describe low voltage lighting control systems and their installation requirements. Identify lighting systems and components and operating characteristics. Describe how to plan and install a basic low voltage lighting control system. And there's a performance task. Mount and connect a 120 volt lighting contactor with 3-wire push button control that your instructor might want you to do. Where lighting systems must be controlled from several points and complex arrangements are required, low voltage remote electrical control systems are applied. These systems use low voltage control transformers to power relays, which in turn control the line voltage circuits and switching devices. Because the control wiring does not carry the load current voltage, small lightweight cables can be used for control. It can often be installed wherever and however convenient, such as behind molding, stapled to woodwork, buried in shallow plastic channels, or installed through holes bored in wall or wall studs. Low voltage switching is especially useful in existing buildings because the small cables are easy to route as telephone wire. Basic remote control switching system is shown in Figure 18. In both circuits, the relay permits positive control to switch the load. It can be located near the load or installed in centrally located distribution panel boxes, depending on the requirements. So here's a low voltage relay. Here's the switch, on or off. When you turn it to the on position, the red side of this is energized, causing this plunger to be pulled out, closing the contact, turning the lights on. But remember, the low voltage signaling part of it is what we're concerned with. It's low voltage, so it's not dangerous. And when you want to turn it off, you turn the switch the other way. Now you've energized the black wire, and it allows the plunger to be pulled back and disconnect the lights. Since branch circuits go directly to the load in this type of system, no line voltage switch legs are required. This saves costly runs of larger conductors through all the switches, and it saves installation labor and materials. Under certain conditions, the NEC allows low voltage conductors to be run in open spaces above ceilings and through wall partitions without further protection. An outlet box is not always required at switch locations. When electricians rough in the wiring, they merely secure a plaster ring to the correct depth at each switch location and usually wrap the low voltage cable around the nail driven behind the plate. Switch or other control is then installed after the wall is finished. So here's a step-down transformer. Step-down transformers like the one shown in the image can provide a low voltage power source for switching circuits. While they're usually found inside equipment enclosures, some simple applications allow some transformers to be secured directly to a junction box where the line voltage is connected to the primary winding. You may also see these transformers mounted on J-box cover plate. You'll see this a lot of times for doorbells, where they have low voltage systems for doorbells. They'll knock a knockout out and just mount the transformer right on the side of the box, and then the low voltage wiring comes out. They try to protect it as well as possible, the low voltage wiring. So it's usually done either up in the top of a closet or at the panel in the garage. So, Figure 19 shows several types of control circuits for lighting. They can often be applied to other control needs as well. The circuit shown, any number of switches can be connected to provide the control for many remote points. In a typical installation, outside lights can be controlled from anywhere area within the building without the need to install larger cables rated for line voltage throughout the building. So here you're using examples of lighting control systems. Here's the line side. They're using a control transformer to step down the voltage, and then the switch will operate a relay that connects the line voltage to the lights, and it goes back on the neutral. Here, the same thing. They're using a small control transformer to step down the voltage, and you can use a two-position switch that will do the same thing. Or here they have a sensing device like an occupancy sensor that when they see somebody in the area, it'll pull the plunger down and cause the lights to turn on. And here's one that's wireless. It's a transmitter. You can run it with batteries. When you push the button, the receiver receives the message and just turns the lights on or off. 3.1.0 System Components and Operating Characteristics. The control relay depicted in Figure 19 is an important part of the system. A relay of this design is shown mounted on an outlet box in Figure 20. Relay installed in an outlet box. So there again, here's the relay inside of an outlet box. You have your line and load, and when the signal comes to it, 24 volts AC, either on or off, it'll move this plunger to either make contact or break contact, and it goes from line to load. Here's the same thing, line to load. They have a two-position switch with 24 volts AC, and when you close the one switch, it pulls the plunger up, turning the lights on. When you operate the other switch, it pulls the plunger down and disconnects the switch. There's the off position. Relay has a split solenoid coil to move the line voltage contact armature to the on or latched position. When energized, the on coil develops a magnetic field that draws the armature up, closing the relay contacts. The armature latches in the on position and will remain there until the off coil is de-energized or energized, drawing the armature into the off position. So relay operation. There again, they're pulling it. They're making contact with the red circuit, bringing it on, pulling the plunger up, or the blue circuit, creating it to come down and turn it off. 3.1.1 power supplies. Here's a highlight. It says transformers used in many control systems supply 24 volts AC, which is safer and common AC voltages for these controls. Most HVACR control systems operate at the same voltage, even though DC power is often used for signaling and communication between devices. AC and DC power are often used in the same control scheme. Figure 22 shows a 24-volt transformer that provides power to electronic circuits. Those devices generally have their own built-in rectifier to power internal solid-state components only. Same 24 volts AC power supply can also power a standalone rectifier that powers system components that are not equipped with their own rectifier. So here's that step-down transformer, and they're saying that some pilot devices have a relay that rectifies it, or a diode that rectifies it into DC. Some transformers will have a diode that will make a DC output. Switches. Rocker switches and two-button switches that provide momentary single-pole double-throw action are commonly used for manual control. With latching relays, the switch that initiates the action does not need to stay closed. Momentary closure is all that is needed to get things started. This approach allows any number of similar switches to be wired in parallel. Here's a highlight, master sequencer. It says a programmable master sequencer allows relays to be controlled as a group while still allowing individual manual control operations. When one external master switch is turned on, the sequencer can stage its own on-relay outputs sequentially. In lighting systems that draw a lot of current, staggering the start of lighting banks can reduce the instantaneous electric load on the system. A local switch can still control an individual output or a bank of lighting without affecting any other. So here they may have several different outputs. Here's 1 through 16 to individual lighting relays, up to 16 of them, and one side is on, that red side is on, and the black side is off. So this master sequencer can turn all of the lights on or off at the same time, and if you come into your office, if you're working late and it turns all the lights out, you can just turn your lights on, and you can override this master sequencer without turning on every light in the building. So Two or more input channels to the master sequencer allows time clocks, building automation system outputs, photocells, and similar devices to also control the sequencer. This approach provides convenient automation coupled with local override for individual banks of lighting. Lighting control system planning. First step in the installation procedure, whether the building is residential or commercial, is to develop a plan. When laying out a control system for a building, drawing symbols such as the ones shown in Figure 24 are used to identify the various components. Here's a highlight. It says, for that reason, it's always important to check the legend on the drawings themselves. And Figure 24 is a common symbol for low voltage drawing. Anything inside the diamond's a widely recognized symbol that is used for denoting low voltage. So there's a low voltage switch, and it's interchangeable type bracket. There's a transformer. There's an extension switch receptacle. There's rectifier assembly, master sequencer or master selector push button switch. Here's a components cabinet. Again, all of these are low voltage. So a relay with a pilot switch. This spec grade number 2 refers to the number of relays. All right. And here's a switch with a pilot light. Low voltage switch with a pilot light. All right. Drawings may be simple, requiring only the following information: the location of each low voltage control with a dashed line drawn from the switch to the outlet to be controlled, a schematic wiring diagram showing the components and their electrical relationships. Plans and specifications often contain a note similar to the following. Furnish and install complete remote control wiring system for control of lighting and other equipment as indicated on the drawing, diagram, and schedules. The system shall be complete with transformers, rectifiers, relays, switches, master selector switches, all plates, and wiring. All control wiring components shall be of the same type and installed in accordance with the recommendations of the manufacturer, except where otherwise indicated. All control wiring shall be installed in accordance with NEC Article 725, Class 2. Many times, architects provide the lighting control system operating concepts. An electrical engineer or designer is then expected to design and install the system to meet those concepts. When the situation occurs, work from the drawings set and use the following general procedures. Assign each light or receptacle a specific control relay. This can be accomplished by using the letters R1 for relay 1, R2 for relay 2, and so forth. Group together all the lights and outlets that are to be switched together. Determine the number of relays that can be controlled by each control module. Divide the number of relays by the number determined in step 3. This is the number of control modules needed to control the relays. Identify the location of the switch points on the building blueprints. Indicate which lights and receptacles are being controlled by which relays. This step can be accomplished by indicating lighting groups on the blueprints. However, it's easier if a switch schedule is used. And review the electrical plans and switch schedule to determine the number and size of switching situations. So here's a floor plan of a residence with both conventional and low voltage lighting. So these are recessed lights, and here's a low voltage switch controlling this light. Here's a bathroom light, and these are not low voltage, these are conventional, controlling the lights in the bathroom. Here's another low voltage switch controlling this recessed light. And I guess there's a low voltage switch here and a low voltage switch here. These are acting like 3-way and 4-way switches. All of these lights together all control the same lights in the hallway. Here's a low voltage switch for a closet. Here's a door switch. So when you open the doors, the lights come on inside the closet. Here's a door switch. Again, this is bedroom number 1, and it actually has a low voltage switch over by the I guess it's got a door that leads out maybe to a garden or something. So you have low voltage switches, or maybe that's where the bed's gonna be, the headboard, and they've got the low voltage switches on either side of the bed, so you can come and get in bed and then turn the lights out. That's kind of nice. Okay. Here's a fireplace, and again, here's a door switch on a utility closet that turns on when you open the door. And they have low voltage switches here controlling this recessed light or this utility room. There's a low voltage switch inside here. These are all on circuit number 3. Here's circuit number 2 in this kitchen dining area. They have a lot of different switching schemes over here. This low voltage switch does this, low voltage switch does this one, this low voltage switch does this one and this one. So, and the garage just has one light in the garage, and it's controlled by a low voltage switch here at the garage door. All right. The schematic wiring diagram in Figure 26 shows the electrical relationship between the components in the single line wiring diagrams. This helps the electrician by providing a simplified graphic representation of the operating sequence. So they're saying that sometimes it's hard to follow these blueprints when you have regular switches and low voltage switches. So they've made it into this kind of a one line diagram that tells you the different circuits, circuit 1, 2, 3, and 4. And circuit 1 does the living room lights. There's 6 of them, all controlled by a relay, controlled by a low voltage switch. And the garage light is controlled by a relay, controlled by a low voltage switch. So here, branch circuit number 2 is in the kitchen and dining room area. They've got 2 overhead lights and a stove light, a sink, two sink lights, 2 counter lights, another 2 counter lights. These are all controlled by low voltage switches controlling relays. These 2 switches control the same relay, so they're acting like 3-way switches to control this for the overhead lights. And in the dining room closet, there's a regular switch. It's not low voltage. And another regular switch in the dining room closet. Okay. All right. Once layout plans have been developed and the materials are required, the installation can begin. Rough inspection instructions presented in this section that follow are only an example. Always follow the manufacturer's recommendations and the NEC requirements, as well as the job specifications. So, enclosures. Here is a highlight. Control enclosures should be placed where it's easily accessible but hidden from sight. Control panels are often powered internally. The interconnecting cables, of course, must be installed. So, manufacturer may place the high voltage terminals of the control panel in one corner, while the low voltage terminals are on the opposite side. This is due to the NEC requirement to keep the low voltage conductors separated from line voltage conductors. There's usually some kind of a separation in the panel between them. The panel itself should be mounted at eye level between 2 studs. All right, that's a highlight. The low voltage panel should be mounted at eye level between 2 studs. The panel is not equipped with a power supply. It's usually mounted adjacent to the panel. The number of transformers needed for a system will depend on the size of the system and the current capacity of the chosen transformer. Switches. Begin by marking the location of the low voltage switches on the walls or studs. Then mount either a plastering or a non-metallic box. A J box is not typically needed for low voltage wiring in most framed construction homes. Preparation of running the low voltage wiring are the same as for running the 120 volt wiring per NEC section 300.4a. If the edge of the hole is closer than 1.25 inches from the nearest stud, a 1/16 inch steel nail plate must be or bushing must be used to protect the cable from the future damage by nails or screws. The wires then roughed in from the switches to the control panel enclosure. They should enter the panel through the opening designated by the manufacturer. They should be approximately 10 to 12 inches long of extra wire length at each switch location and 12 to 18 inches left at the control panel. The extra wire is needed to ensure there's enough to neatly make the final terminations. And make sure you put a piece of tape on them, either masking tape or a piece of white phase tape, and write with a Sharpie or a fine felt tip pen where the switch is located. Bedroom number 1 switch, bedroom number 2 switch, door switch control, master bedroom. Make sure you know what those switches are doing so that when you terminate them, you can control them all correctly. Multi-conductor cables are commonly used for low voltage work. It's essential that cables be clearly marked to identify the individual control circuits. Remember that the colors of the low voltage AC control wiring should not be the same as those used for the DC and line voltage conductors. Roughed in and marked cables and wires should be protected with a plastic bag and shoved behind the plaster ring or rolled up inside the plastic box. This will prevent the markings from being covered over by paint or plaster as the walls are being finished. The low voltage wiring should be kept apart from the high voltage wiring whenever possible. If low voltage and line voltage cables must be placed in parallel runs, they should be separated by at least 6 inches. Otherwise, the noise generated by the line voltage conductors could interfere with the operation of the low voltage system. All right. So they're saying you might have some induced currents in the low voltage wiring. Section 3, review a device that allows lighting relays to be controlled in groups while still allowing individual switch control is called a what? And where low voltage cables must be run adjacent to line voltage cables, the two should be separated by a minimum of how many inches? Well, this concludes 26.211, control systems and fundamental concepts. And I hope you got a lot out of this video. And as always, give me a thumbs up and consider subscribing to my channel. And I'll see you on the next video. Thank you. Hey, this is Brian Young. If you liked my video, please give it a thumbs up and consider subscribing. I'll see you on the next video.